And to start off with, we'll talk a little bit in the area of biological control. And what this poster is, which won't stay still, this is some work we've been doing with a fungus, okay? That's a parasite of nematode eggs, Bacillomyces lilicanus. And this fungus, there's certain strains of this fungus that are naturally occurring in Florida and other places. But nematode eggs produce antibiotics, and every type of nematode makes a different type of antibiotic that protects those eggs from organisms like this Bacillomyces. And so the one we've been working with is this strain 251, okay, which originated from the Philippines, and we've been working with it now in a couple of years. First time we tried this thing, didn't work, okay? And we applied it in May on a couple of golf courses and did nothing. And so we went back and looking at it, and what we've been learning about with sting nematode reproduction is that the nematodes tend to do most of their reproduction during the springtime. And so last year we decided to back our applications up to start applying the stuff in February, and we applied it at 6-week intervals. We applied it 3 times, and what we found was that we had, you probably can't see this very well, but this is our nematode production, these Bacillomyces treated plots, and the untreated. You see here we got a reduction, then the population has crossed the untreated too. And up here, this is again the untreated controls and the treated plots. So we're getting fairly good nematode reductions with this, doing it that way. So we repeated the trials this past year. We actually started applications this year in November. And what you're seeing here, they're kind of bouncing around, but when you get into transition, in both of the trials we had significantly lower nematode populations. And so we're getting fairly consistent sting nematode reductions with this. Now I will say it's not like a huge, wow, we killed all those sting nematode type of effect, okay? And I don't think this is going to be a product where if you got a big nematode problem, you're going to put this out and cure it right away. But what we are finding is that with regular applications of this through the winter and springtime, we are lowering our sting nematode pressure during transition time, which is when the nematodes do most of their damage. If you look here, this is the Bermuda grass roots in our plots from this year, our 2 golf courses we worked on. And these are the roots in our untreated controls, Nemacure, and our Bacillomyces treated. And you see we're getting significant improvement in the turf lengths as well. So we are protecting these roots to some degree. So this Bacillomyces strain 251 has now been EPA approved. So it could be on the market as soon as next year. So, and again, I want to stress it's not a curative treatment, but is something as part of an IPM program that'll help reduce nematode pressure. Also, we have not had any effect with this on lance nematodes, only on sting nematodes. Remember I told you these different nematodes have different antibiotics that affect different types of these types of organisms. But for sting nematodes, it is having an effect. Another organism we're working with is Pasteuria usgi. And you may have seen we just got grants from the Florida Golf Course Superintendents and GCSAA to work with this. This is a bacterium. And this is a bacterium that's an obligate parasite of sting nematodes. Unlike this fungus we talked about here, which is a facultative parasite, this bacteria only feeds on sting nematodes. And it attaches to the sting nematode, injects itself into the nematode, fills the nematode up with bacteria. The nematode dies, releases thousands of these bacteria out in the soil that are attached to other nematodes. And Robin Gimlin Davis, my counterpart down at Fort Lauderdale, our other nematologist works with turf some, has worked with this a few years back with natural inoculation with it, and showed it to suppress sting nematode populations of putting green. What's new is we've been working with a company here in Alachua, Pasteuria Bioscience, and growing this bacterium in vats where you can grow it and develop it to a commercial product you can go and apply. And so the company now is producing this in 20-liter vats, and able to supply us quantities of spores. We've been working with them on cleaning up the material, making sure it attaches to the nematodes. Now we're at a point where we've got some real good attachment with the bacteria on the nematodes, and we're able to start now testing with it. So we're going to be finding out how many of these bacteria you need to apply, how best to apply them, when to apply them, all those types of questions. So again, that was probably going to be a few years out, but hopefully that'll turn into something that'll be a commercially available biopesticide product. But some of these things we're looking on the long-term side have some real huge efficacy associated with them. Now, whether they can get registered or not, that's another question that EPA has to work on. So look at a lot of different things there, working with some Again, some botanicals. Well, out there I have some plots which you guys don't necessarily know to look at. It's really nothing to see at this point, but we are working with some botanicals that I would say I haven't been overly impressed with. And we're also looking at some nutrient package combinations, trying to enhance tolerance to nematodes to different fertility programs and things as well.